So in this video, we're going to discuss the introduction ng mga methods in solving first-order differential equation. So ang ibig kong sabihin dito is that we're going to introduce the methods used in solving a first-order differential equation. So before that, ano yung first-order differential equation? Ang first-order differential equation, it is a differential equation, of course, that has first-order derivative notation or first derivative notation ang tawag tuloy ang meron sa equation na to. Okay? So ulitin ko, first-order differential equation is basically a type of differential equation na mayroong first derivative notation or first-order derivative notation. So ano yung tsura ng mga first derivative notation? So ganito siya, di ba? dy all over dx. Okay? O kaya pwede siyang y prime. Okay? O kaya ibang letter naman, r prime. Pwede rin kasi itong isang apostrophe sa isang variable, ibig sabihin ng first order derivative yun. Okay? Or we can use different format. dr all over dt. Okay? And so on and so forth, and many more examples. Okay? Ito, first order naman siya, it's so obvious. Kasi kapag ginawa mo tong second order, okay, for example, ito yung binilugan ko. Kapag ginawa ko tong second order, ganito maging tsura niya. d squared of y all over dx squared. Ito, second order na to. Okay? So, kapag third order kaya, ganito yung tsura niya. d cube of y all over dx cube. So, this is third order. Okay? So, dapat sa differential equation, maging first order siya kapag ito ang given mo lang. Ito lang. So, let me give you some examples. Okay? Ano yung tsura yung mga first order differential equation? So, for example, we have x times dy all over dx plus y is equal to 0. Another example, ito, let's just say we have quantity x minus y times dy plus quantity y plus x times dx is equal to 0. Now, take a look. These two examples are first order differential equation. So let's dig in deeper. So first example, bakit kaya first order to? Okay? Kasi dito, sa differential equation, meron siyang isang given na derivative notation, which is ito. At itong derivative notation ay naka-first order. Sa second example, first order pa rin ito. Okay? Ang pinagkakaiba nga lang is that sa first example, magkahiwalay si dy at saka si dx. Magkahiwalay silang dalawa. Alright? So, big sabihin nun, pwede natin siyang i-separate. Okay? So, try nga natin gawin ito. Ito. Like, can we make this equation similar as this equation? Try natin Okay? So, isolate ko siya dito. X times dy all over dx plus y is equal to 0. Una, transpose ko si y sa kanan, magiging ganito siya. X times dy all over dx is equal to negative y. Tapos, pwede ko i-cross-multiply. Multiply ko si dx kay negative y, magiging x times dy is equal to negative y times dx. Okay? Then, ipag-combine ko si x dy tsaka si negative y dx on the left side of the equation, ganito maging tsura niya. X dy plus y dx is equal to 0. Ayan. O diba? So, medyo similar na sila dito sa example na to. Okay? So, ganyan yung tsura ang mga first order derivative notation. What if meron tayong notation na hindi lang si first order given, pero merong second order? Hindi na first order nun. Ang tawag mo na sa kanya ay second order differential equation. Kasi remember, in order for you to determine the type of differential equation, you need to know its order. At yung order ng differential equation ay yung highest order derivative meron doon. So kapag meron kang second order na derivative notation sa isang first order differential equation, then hindi na yung first order. Second order ng tawag. Now, we know already kung ano yung idea ng first order differential equation at saka yung mga example niya. Now, let's proceed sa mga methods. So, the first thing we're going to discuss is a separable variable. Ang separable variable is basically, on both sides, dapat magka-partner yung dalawang variable. Hindi, wait lang. Suppose, kunwari, meron tayong x at saka si y na variable. Okay, suppose meron tayong ganun. Dapat on both sides, okay, kunwari on the right side, si f of x, dapat kapartner niya ay si dx. Then on the right side, ang kapartner ni f of y ay si dy. Gets niyo ako, guys? So kunwari, meron tayong x at saka si y as your variables. Okay? So on the left side, meron tayong f of x and on the right side, meron tayong f of y. Kunwari lang to So kung meron tayong f of x sa kaliwa, then dapat ang kapartner ni f of x ay dx. Then, ang kapartner ni f of y sa kanan ay dy. So it means, if you have f of x, anong kapartner niya? Dx. Kung meron tayong f of y sa kanan, anong kapartner niya? dy. Okay? So we're going to integrate them both sides afterwards once they are both partnered together. Okay? Pero what if dito sa function na to or isa sa kanila, meron siyang isang variable doon na hindi magkatugma. Okay? So kunwari, on the right side, left side pala, meron tayong f of x and y in terms of dx. Okay, tapos on the right side, f of y lang siya. Ito, kapag ganito yung case, we are not going to use separable variable. Kasi dapat, okay, on both sides, kung anong kapartner ni x, siya si dx. At kung anong kapartner ni y, siya si dy. Yun lang yun. Alright? So itong sa second example, on the left side, meron tayong f of y and x, or f of x and y. So meaning, dalawang variable ang ginamit dun sa left side. Okay? So, meaning, hindi to separable variable. Okay? Kaya nga nakalagay separable variable, ibig sabihin nun, dapat magkahiwalay yung dalawang variables. One on the left and one on the right. So kapag may isang variable hindi magkahiwalay, then hindi pwede si separable variable. Alright? So, that is separable variable basically. Don't worry, yan yung una nating i-discuss in the next video. Alright? So that is separable variable. Next is meron tayong homogeneous differential equation. Ano ulit yung homogeneous? So, if you're going to recall, ang homogeneous, di ba, is meron kang isang given na differential equation tapos on the right side ay equal to 0. Right? So, bigyan kita ng example. Let's just say yung kanina, yung, wait lang yung x times dy, wait lang, ayusin ko lang ito. Wait lang forgive me. Ayan. X times dy all over dx minus y is equal to 0. So ito, homogeneous to. Bakit? Kasi dito, on the right side, it is 0. Yun yung tinatawag natin na homogeneous differential equation. Pero there's one thing I did mention sa introduction. Okay, di ba sa introduction? Hindi sa introduction pala. Sa linearity and homogeneity video. Di ba may sinabi ako na what if meron tayong ganito? Quantity x minus y times dy plus quantity y minus x times dx is equal to 0. Kumbaga, magkahiwalay si dy at saka si dx and meron silang kanyang-kanyang mga partner na nakaparenthesis katulad nito. Okay, si dy may x minus y. Si dx may y minus x, di ba? So, is this homogeneous o hindi? So, dito kasi, kapag magka-partner tong si dy all over dx na naka-fraction, it's easy for you to determine whether if it's homogeneous or not. However, how about this one? Yung magkahiwalay si dy tsaka si dx, how would you know if it's homogeneous or not? So, dito, it's easy. Tingnan nyo lang yung degree ng isa't isang mga term. Itong si x, anong degree ni x? Di ba? 1. Anong degree ni negative y? Di ba? 1. First degree. On the right side, si dx. Si y, naka-first degree to, di ba? Tsaka si negative x, naka-first degree. So, as you can see, all of the terms have the same degree. So, ibig sabihin nun, this is homogeneous differential equation. At meron siyang specific formula for that. So, bottom line, if you encounter a first-order differential equation that is a homogeneous type, then dapat lahat ng degree ay pare-parehas. Bigyan kita na example. Two more example. So let's just say we have quantity x times y plus y squared times dx minus quantity x squared minus y squared times dy is equal to 0. Now, let's check yung mga degree niya. Ito, si xy, tingnan mo yung exponent ni x. Yung exponent ni x, o yung degree niya, is naka 1. Tapos, itong si y, ganun din naka 1 siya. So, according sa basic lesson natin sa algebra, kapag meron tayong isang term na may dalawang variable magkadikit-dikit, tapos you're asked to find a degree, ang gawin mo lang is i-add mo yung dalawang exponent nila. So that means we're going to add the exponent of x and y to get their degree. So ang degree ng xy ay second degree. Kasi 1 plus 1 is 2. Okay? So that means yung first term ay naka-second degree. Now, dito sa y squared, yung exponent ay naka-2. So that means ito ay naka-second degree din. So on the right side, we have dy. So si x squared, naka-squared siya. So that means naka-second degree pa rin. And itong si y squared, ganun din, naka-second degree. So this is homogeneous differential equation. Okay, ganun siya. How about this one? X minus y squared times dx plus y squared minus x squared times dx is equal to 0. Tingnan natin yung degree niya. Itong si x, since yung exponent niya naka 1 lang, so ibig sabihin ito ay naka first degree. Itong si y squared, naka second degree to. And si y squared tapos si negative x squared on the right side, naka second degree sila. So, are all sorry, napikon ako tuloy, sorry. So, are all of the terms are the same in terms of their degree? The answer is no, not all are the same. Kasi ito, first degree lang to, while the others naka second degree. Therefore, this is non-homogeneous. This is non-homogeneous na to. Okay? So, that is non-homogeneous differential equation na. Alright? So, para naman sa mga non-homogeneous differential equation, was there a formula na gagamitin mo? Okay, how would you solve a non-homogeneous differential equation? Well, the methods that you can use in solving a non-homogeneous differential equation ay either exact DE, non-exact DE, Bernoulli equation, inspection method, or folde. Pero depende lang sa folde . Okay, depende. Kasi pag folde, itong si first order linear differential equation, dapat linear talaga ang iyong first order differential equation. Kasi kung hindi, baka gagamitin mo si Bernoulli. So, dito, let's talk about non-exact DE. Non-exact. Let's talk about exact DE. So, si exact DE naman, okay, gagamitin mo lang to if, ito bigyan kita ng example. let's just say, meron tayong ganito. Okay? Sorry, nagbubuks ako ng notes. Alright? So dito sa non-exact, meron tayong, non-exact tuloy, exactly. You will know if they are exact if the partial derivative of m in terms of y is equal to the partial derivative of n in terms of x. So, sino si m at sino si n? Okay, like sino si m at sino si n? So, di ba usually, yung first order differential equation, di ba, it's either magka-fraction si dy all over dx or magkahiwalay si dy at saka si dx at may kanyang-kanyang silang parenthesis, di ba? So, kunwari, meron tayong ganito, x minus y times dx plus y plus x times dy is equal to 0, di ba? So ito, let's represent this one as m and n functions. Okay? So, dito, wait lang, burahin ko lang to. Let's say na meron tayong a function m of x and y times dx plus function n of x and y in terms of dy is equal to 0. Yan. So, kung kukunin mo yung derivative ni m in terms of y at saka derivative ni n in terms of x, and they are both the same to each other, then it means this is exact differential equation. If and only if partial derivative of m in terms of y is equal to the partial derivative of n in terms of x. So ito yung tanong, is it applicable sa isang homogeneous differential equation? The answer is yes. It is still applicable, pero it depends. Okay? Depende. Because what if they are not, itong equation na to, itong binilugan ko, what if they are not equal to each other? So if they are not equal to each other, anong tawag mo sa kanila? Non-exact DE. Okay? Non-exact DE naman. Alright? So, pag non-exact differential equation, that means partial derivative of m in terms of y is not equal to the partial derivative of n in terms of x. Yun yung si non-exact. Alright? Then next, meron tayong first order linear differential equation or FOLDE. By the way guys, what I'm doing here is I'm just introducing the types of first order differential equation and ano yung mga methods niya and is it applicable to a given first order differential equation or not. Okay? Di naman tayo magsosolve. Parang discuss lang. So first order differential equation or tinatawag natin na FOLDE. Okay? Ang formula nito actually is this one. Okay? dy all over dx plus p of x times y is equal to q of x. Okay? Ito yung formula ng first order differential equation. Okay? Dapat ganito talaga itsura niya. Okay? Dapat yan talaga itsura ng first order linear differential equation because this is the standard form ng isang first order differential equation. So what are the examples yung mga first order differential equation? First order linear differential equation pala. So kunwari, meron tayong ganito, okay? dy all over dx plus sabi natin x times y is equal to 1 all over x. Kung mapapansin mo, yung coefficient ni y ay isang function of x, which is meron tayong x. And on the right side of the equation, meron tayong function ng x dito na 1 all over x. So ito ay isang example na first order linear differential equation. Alright? Well, how about this one? Kunwari, meron tayong ganito. Quantity x minus 1 times dy all over dx minus y is equal to 0. Is this first order linear differential equation? So malalaman mo yan if you convert this one into the standard form of it. So try ko nga. I'll try to divide both sides of the equation by x minus 1. What will happen is that we will have dy all over dx minus y all over x minus 1 is equal to 0. And try kong ibaba si y sa gilid. Ano mangyari kapag binaba ko si y sa gilid? So mangyari dyan, we will have 1 all over x minus 1 times y is equal to 0. So as you can see, meron tayong dy all over dx. Tapos meron tayong function dito na in terms of x, which is negative 1 all over x minus 1. And we have on the right side a function of x pero constant 0. So folde pa rin to. It is a first order linear differential equation pa rin. Okay? So basically, yung ang first order linear differential equation, dapat ganito tsura niya. Okay? And one more thing, diba linear siya? So when we say linear, dapat, nung sa discussion natin sa introduction, pag linear siya, ibig sabihin, yung dependent variable mo, dapat yan lang siya. Hindi siya naka-trigo, hindi siya naka-exponential, hindi siya naka-squared or may exponent pa man, ganyan lang siya. So dito, tingnan nyo to sa example na to. Okay? Take a look at the two examples. Yung dependent variable natin is obviously y, di ba? So, itong si y, yan lang siya, di ba? That's basically y. So, that's good enough. On the second example, meron siyang negative y dito. So, that's also good enough. Okay? Linear na yan. Kasi yan, kapag yan naka-squared, or kapag yan naka-square root, or kapag naging trigo yan, like imbes na y, naging sine of y yan, o kaya imbes na sine of y, naging e raised to y, hindi na to linear. Okay, that's already a different scenario na to. Hindi na to linear. So, make sure that dapat linear siya. Alright? So, let's just say meron tayong y. Okay. Pero, meron pa tayong isa pang y, pero siya ay naka-exponent. Hindi siya hindi siya ang simple y rather kunwari on the right side, let's just say ito on the second example, quantity x minus 1, wait nga lang, medyo nagugulat. Sorry, yan. So quantity x minus 1 times dy all over dx minus y, tapos on the right side meron kang y squared. So if you have another y variable at meron siyang specific na exponent dito, which is not equal to 1, by the way, then ang gagamitin mo rito ay Bernoulli equation or Bernoulli's equation. Mali yata ang pagkasulat dito. Pero Bernoulli's equation gagamitin mo rito. So, anong tsura ng Bernoulli's equation? Ang tsura ng Bernoulli's equation, yung formula niya is just almost the same lang sila ng first order. They are just almost the same. Pero ang pinagkakaiba is that on the right side of the equation, meron kang function na na x, pero meron ka pang isa pang y variable na may specific exponent na n. At yung n na to should not be equal to 1. Okay? So ano yung mga example? So kunwari, meron tayong dy all over dx minus x times y is equal to y squared all over x. Kung ibaba natin si y squared sa gilid, anong mangyayari dito? We will have 1 all over x times y squared. So ito, we have a function na x, which is q of x. Then sa gilid, meron tayong y squared, which is a y na merong exponent na 2, which is not equal to 1. So pwede siya negative, pwede siya positive, okay? Basta hindi siya equal to 1. So yun, gagamit ka ng Bernoulli equation. Okay? So that's all for Bernoulli's equation. And don't worry, there will be more formula, the same thing kay Folde or first order linear differential equation. There will be specific formulas for these two. Alright? So lastly, meron tayong inspection method. So itong si inspection method, ano lang to parang ano to integrable combination yata tawag nito if I'm correct. It's like this do you still remember the product rule, quotient rule? Do you remember those? So kunwari I ask you na meron tayong derivative of x times y. Okay? So kung gagawin natin tong product rule, 'di ba ganito maging tsura niya? X times dy plus y times dx. Okay? Kung naalala niyo yung yung discussion ko sa rules of differentiation, kunwari, the derivative of u times b, this is u dv plus v times du. 'Di ba? So parang ganun lang siya dito. It's just the same as this one. All right? So ano pa? Quotient rule. Ito pa, quotient rule. Ay, teka lang sorry. Quotient rule. Ito pa. Let's just say the derivative, sorry, the derivative of x all over y. So we have y times dx minus x times dy all over y squared. Diba? So, there are other differentiation rules nito na i-apply mo yan sa pagkuha ng solution ng isang first order differential equation. Okay? So, for example, bigyan kita ng example. Let's just say meron tayong ganito. X times dy plus y dx is equal to 0. And I want you to get the solution for this one. Okay? Ito i-spoil ko na to sa inyo Spoil ko na to sa inyo. Itong si x dy plus y dx, di ba, is just the same as the derivative of x times y. So I can just simply substitute this one as the derivative of x times y is equal to 0. O, di ba? Tapos, after that, I will just integrate both sides. Okay. Ang mangyari dyan, if I'm gonna integrate both sides, makakancel tong si d sa left side, magiging xy lang siya. Tapos on the right side, meron lang tayong 0 pa rin, tapos may plus c sa dulo. Okay? So, ang sagot ko rito ay c. O, diba? So, that's my final answer. Okay? Or, you can have plus c sa kaliwang side, tapos sa kanan, 0 lang siya. Okay? Because you cannot have dalawang plus c on both sides if you're going to integrate both sides of the equation. Dapat, isa sa kanila may plus c lang. I-explain ko yan in the next video. Pero yun nga, I already spoiled you guys kung ano yung application ng inspection method. So basically, yeah, parang ganun lang siya. Okay? Hindi lang to ang gagamitin natin. There are like one more or two more na differentiation rule na i-apply natin yan sa inspection method. Alright? And there are like one more other methods pa, but that would be next time na lang i-discuss natin. For now, we will discuss these methods of first order differential equation. Si separable variable, homogeneous differential equation, exact differential equation or exact DE, then non-exact differential equation, then first order linear differential equation, Bernoulli equation, and inspection method. So as you can see, parang the way how I explain it, parang gist lang no? Gist lang, parang hindi siya ganun ka-specific na detail. Alright? Maybe I can give you some examples, pero still parang may kulang pa, di ba? Because actually, I really don't wanna spoil you in general kung ano yung gagawin nyo rito. Kasi this is just an introduction. Okay? Ang contradicting nun is that ginawa ko pa naman yan sa inspection method. No? Pero at least, nakuha nyo na yung idea rito. And since, yung kanina, yung pagka-solve ko na example sa inspection method, di ba, nag-integral ako. Expect that yan ang gagawin natin. You know? Especially sa separable variable, yeah, we will also use that. All right? So, in here, we will have, yes, solutions or answer if we use the correct method. And pumili lang kayo dyan kung which one is better. But still, we have no idea kung paano natin itong gamitin. So let's discuss them one by one. All right? So without further ado, so let's proceed na sa next video, which is about the usage of separable variable in solving a first order differential equation. See you